Actually, a very good afternoon.
Good afternoon, sir.
Actually, can you listen me?
Yes, sir. Yes, sir.
Oh, great.
Good afternoon, sir.
Good afternoon. How are you?
I'm good. I'm good.
That's good.
Actually, I am in
Yes, please speak. I'm listening you.
lab, yeah. Electrical machine lab.
Are you in class?
This one is lab. Lab station.
Actually, just actually no one have attended, so just I want to know. Okay, that is lecture is mine now. Am I right?
Yes, yes. I'm saying this one is lab station of electrical machine lecture.
Yeah, that's my lab that I can see, and actually only few persons have joined. It's for A batch. A batch that is only for MU student. Am I right?
Yes, yes.
Okay, that's fine. Okay, so all of you can see the screen now. So only 4% have joined. Just I'm waiting for only few minutes, then I will start my session. No problem. Okay, so I think so. No will other join. Only 4%. 4% is there. Okay, so just I'm starting session now. I don't think there is no need to wait for any more now. We call it 12:10 is there. Okay, so just I want to know how many experiment have done before? Anyone? How many experiment already have done? First of all, this updated
five experiments, sir.
5 experiments have done. Okay, great. Already, this is the EM2 lab, electrical machine 2. Clear? So, just I will discuss about this lab, that what's going on and what we can do something new and what we have done before, that I will discuss today. And then after I will start my practical also, because today is the online session. So first of all, I will try that we'll complete all the theory work. And after that, I will, whenever your session will be offline, means in next lab, we'll try to perform the practical by physically lab, in physical presence, because that's practical very, very important. So that's why physical presence and the practical that already will do in the physical lab, that will be good for all of you. Okay, so just wait. Okay. Sorry for this. Something problem is there, something noise. Just I have to stop. Okay. So all of you can see the screen now. All of you can you see the screen now?
Yes, sir.
Okay, great. Okay, so just I will share the screen, and already I will share the screen. I'm sharing the what we'll do today. In today's lab, we'll perform 6 experiments. That is called to obtain direct access and quadratic access. That is called XD and XQ. Clear? This is called reactance of a silent pole machine with slip test. Okay. Now, before solving this topic, before performing this experiment of XD and XQ, first of all, we must know that what is the meaning of XD and what is the meaning of XQ. In this type of machine, we are finding XD and XQ. Okay. So today I'll discuss first of all what is the meaning of XD, what is the meaning of XQ, why they are coming in the process, why we are performing this test with the help of slip test only. Okay. So I will discuss today, and then I'm going for the next screen. And second thing, this is your list of experiment. This is your list of experiments. So I think so already you have said that experiment have done. So can you call me the number which experiment have done? You can see the screen now. Can you tell me which experiment? Can you give me the number of that? Anyone, can you recall me that which experiment have done? You have said 5, but can you call me the name? Like first experiment to obtain speed characteristic, like that.
We've done experiment 4,
Okay. You have done essay number 4.
3, 3,
So 4 you have done. 3 you have done.
2,
2 also good.
also 1. I
Also
think we've
1.
done. Yeah, we did 1.
Okay. Any else? Anything else? Only 4? Anyone? Only I have done 4 experiment. Okay, in chat box they have written that 9 also. Actually, they have written 9. So I'm also taking for the 9. Okay, no problem. So just I'm going for that. So already we have got in some 9 else remaining. Okay, all else all remaining. Okay, done. So if there's 5 experiment that is also not done. This one. Because already Bhavak sir told me that they have done 1, 2, 3, 4, 5, 6. Sorry, 5 and 9 and one more. So they have said, but we have to start to 6. If 5 is not done, don't worry, I will do. Okay, I will do 5 also. Okay, now first of all, what is sleep test? Because already I said first of all, you must know what is sleep test. Clear? So if we are talking about sleep test, so this method used to determine xt and xq, that is called the direct and quadratic axis reactance. It's called sleep test. So first of all, before discussing about the slip test, can you explain what is slip actually? What is slip? SLIP. What is the meaning of slip first of all? Anyone can you call it what is slip? No one can say what is slip.
Yes, sir.
Yeah, please speak.
Your question is what is the slip?
Sorry, actually, I can't hear properly. So can you repeat again?
You are asking a question about slip?
No, not actually question. Just I'm asking first of all definition. We can say define. How can you define slip?
Okay.
Means
Slip means
definition means how can you explain slip? That's I want to know.
it means it is the difference between the synchronous speed and the speed of the motor. This is like the synchronous motor.
Okay. Anything else? Anyone want to say something? Anyone want to say slip? What is slip? Okay. So no one want to say about the slip first of all. The difference in speed of rotating magnetic field and rotor speed. Good, Charles. That's good. So I think, of course, this is very simple thing that what you are understanding here that I'm saying the same thing to you. That first of all, we must know that what is slip. So already, I think so 2 to 3 have got difference that those who also have answered in chat box, and Charles also have said something. So that's too good. So actually, the slip that's very well. That very well you have said. So anyone, actually, there was one more question to you. Can you tell me what is the working principle of induction motor? And do you know what is the meaning of silent pole and non-silent pole? Anyone? What is the meaning of silent pole and non-silent pole? That actually why I'm asking, so that we can start from the basic and we can do for something. That's fine. Okay, so no answer I am getting. Okay, no problem. So first of all, that already have got reply from all of you. That's good also. Seriously, that's good. That this is called ns minus nr. Okay, Josu already have said. So the equation that you know very well, that is ns minus nr upon ns. Okay. So that's very simple equation that you know. And actually the problem is that slip is nothing else. That's a difference between both the speed that you have already said in terms of single speed, and we can say ns and nr, that is called rotor speed. So the thing is that first of all, that already you have said the slip. So that's I'm just asking about the slip, that what is the important caution for conducting slip test? Because if you're performing slip test to find x and xq, so what are the cautions for conducting for slip test? Number one, slip should be extremely low. Now that already you have said, if you are talking the percentage slip, that is called ns minus nr divided by ns into 100. So if I'm saying that slip must be extremely low, so what is the meaning of this line? Anyone? I'm just asking the relationship between these two speed. Means, of course, ns minus nr. If you are saying slip should be extremely low, means If this is value is very low, it means this ns minus nr must be very less or high. Anyone? ns minus nr difference must be low or high. Perfect. So those who have replied, good. Any more reply? Of course, very less. Joseph said perfectly that will be very less. Why? If this is less, so upon ns, for example, I'm giving the example. Suppose I'm saying your ns for the 2-pole machine or for the 4-pole machine. For the 4-pole machine, anyone can you give me the answer? For 4-pole machine, what will be the speed ns? Which formula you will apply? Anyone? For 4-pole machine, which formula you are going to apply for ns? Can you give me? Yeah, perfect, perfect. Actually, you have given the answer. That's good. ns equal to 120 FIP. Perfect. 120 FYP. So, can you give me the speed for the 4-pole machine? Anyone? Just use the calci and use the calculator and give me answer. $1,500. Perfect, perfect. 30F. Already he said 30F means already that is for 1,500. So now already you have got that the speed is 1,500. Clear. Now if the speed for the 4-pole machine is 1,500, and if I am saying the rotary speed will be nearly 1,450. 1,450 or 1,440, whatever. So if you are calculating, can you tell me what will be the slip? If rotary speed will be nearly equal to 1450 or 1440, and the ns, that is synchronous speed, will be 1,500, what will be the slip? Calculate and tell me. Just a minute, I'm saying to all of you. Okay, so just I'm saying first of all, in an alternator, what is alternator that is called? Synchronous machine. So in an alternator, we apply acceptance to the field winding that is called prime mover, if you remember. Can you tell me that how alternator can work, that how synchronous machine can work? Anyone? How an alternator works, can you tell me? How an alternator works, can you tell me? That you know, alternators are not self-starting. We have to give some excitation in terms of prime mover in synchronous machine in alternators, if you remember. Okay, so in alternator we apply excitation to the field winding and voltage gets induced in the armature. That's a working method. But in the slip test, a three-phase supply is applied to the armature first of all in induction, and that is called in silent pool machine, having voltage much less than the rated voltage, while the field winding circuit is kept open. Clear? So you can see the circuit diagram also in the next one. From this test, the values of XD and XQ are determined by applying a balanced reduced external voltage, say V volt, around 25% of the rated voltage to the armature. Okay. From this test, the values of XT and XQ are determined by applying a balanced reduced external voltage, say V volt, around 25% of the rated voltage to the armature. The field winding remains unexcited. Keep in mind, the field winding remains unexcited. The machine is run at the speed at a little less than zero speed. So the slip being less than 1% using a prime mover or motor. So for this test, we have to perform this test we can perform on the DC motor and three-phase induction motor. That is a combination of that one. Okay. Sorry, that's alternating that equals silent pole. So this is the current. This is circuit diagram. You can say this is your synchronous machine. You can see. So this is your rotor. This rotor, you can say this is the rotor. Clear? And this is the armature winding that you can see. Clear? So what we are doing, we are just keeping open. Clear? Just we are keeping open this winding and we are applying some. You can see this field winding is open here. Clear? So keeping field winding open, we are applying some voltage on the rotor side, rotor winding that we can see. Clear? So this circuit diagram too, you can take a screenshot also. Just I'm playing the screen. So with this screen, this circuit diagram we will apply and we will perform the practical. Now, how can you determine XT and XQ? So due to voltage V applied to the stator terminal, a current I will flow, causing a stator MMF. This stator MMF moves slowly related to the poles and induced an EMF in the field circuit. Okay, due to voltage V applied to the stator terminal, a current I will flow, causing a stator MMF. This stator MMF moves slowly relative to the poles and induced an EMF in the field circuit in a similar fashion to that of rotor in an induction motor at self frequency. So the effect will be that the stator MMF will move slowly related to the poles. The physical poles and the armature reaction MMF are alternately in phase and out, the change occurring at self frequency. When the axis of the pole and the axis of the armature reaction MMF wave coincides, the armature MMF acts through the field magnetic circuit. Since the applied voltage is constant, the air gap flux would be constant. When crest of the rotating armature MMF is in line with the field pole axis, minimum air gap offers minimum reactance. Thus, actually, that first of all, and just I want to share one more thing to all of you. What is the difference between silent pole and non-silent pole? Anyone? Already I've asked this question. I'm just setting the whiteboard. This time asking to everyone. What is the meaning of silent pole? And then if I'm giving to a question to all of you that how can you make a difference between silent pole and non-silent pole? Silent pole and non-silent pole alternator. Can you tell me? Anyone? First of all, in which type of alternator speed will be high? In which type of alternator speed will be high? Silent pole or non-silent pole? Tell me. Number one difference, number two difference, some difference I want to listen to from all of you. So please you can speak now. You can write in the chat box also. I'm listening to all of you. All of you can write in the chat box also what is the difference between silent pole and non-silent alternator. That already you have that I think so this is completely in your syllabus also. So no answer from all of you. Difference between silent pole and non-silent pole machine. There are 5% is there. Estilo, Charles. I'm waiting for all of your answers. Okay, so someone have written chat box. I'm just checking. Okay, so Charles is saying silent pole machine have typical speeds speeds between speeds of between 100 to 70 rpm. Silent pole generators will have large diameter and short axle length. Good. Please write. No problem. I'm reading all of you. Whatever you're writing, I'm reading, and then I'll be summarized. So you can write more, whatever you if you have the knowledge. Non-silent pole are used for the high speed operational, typically speed this and this. Good. That's okay, no problem. Charles, that's seriously, that's good. At least you have replied. Only 1% chance that you have replied. So Charles have given many reply. First of all, Charles have said that the speed of silent pole motors, that is called, we can say, and if I'm talking the speed, so speed is very very low in silent poles, and in non-silent is very very high. That's good. Clear? That's good. That's good. Now, so Ashur also said that silent pole rotors have large diameter and shorter axial length. Yeah, perfect. On the same thing already they have said large diameter, short axial length. So we can say D is always high and L is always small. So on the other hand, D is very very less and L is very very high. Okay. Number 3, we can say, now just to give me very normal question to all of you, I want to ask. If N is low, so number of poles will be high or low? I'm asking, I'm repeating my questions. I think so. You didn't get the question. If speed of silent pole machines is less, number of pole will be high or low? If I'm comparing,
Sorry, sir. Come again.
I'm asking, listen, that's very simple question. I'm asking, if silent pole machine having low speed, number of pole will be high or less?
I think it should be high.
Yeah, it should be high. Can you justify your answer with any mathematical equation?
Because the speed and number of pole is inversely proportional. We already have seen in the equation.
Perfect. Because n equal to 120 f by p. Great answer. That is called f20 by 120 by p. And you know, frequency always fixed in India. Am I right? Frequency is always fixed in India. So that's why if frequency is fixed, so ultimately n depends upon 1 upon p. Am I right? So the third difference we can say is speed for silent pole is very low, and that's why number of pole for the same structure for the same power rating will be very high. Am I right? And on the other side, speed for the non-silent pole is very high. That's why number of pole will be very less. So that's why most of our machines, they are representing only 2 and 4 pole. While in this machine we are having that is called 8 pole, 16 pole, 32 pole. Are you getting my question? Clear? Second thing that if you remember, that is called non-silent pole is also known as cylindrical. Am I right? Clear? Silent pole and non-silent pole machine. Which one is called cylindrical rotor? Anyone? Which one is called cylindrical rotor?
Non-silent.
Non-silent is called cylindrical rotor. Am I right?
Yes.
And for difference, actually that's I want to give you difference because this is very important question. Hopefully this question can appear for the midsem also. Fourth difference, can you tell me in which machine your air gap, length of air gap is not uniform, non-uniform, that is called? I'm asking in which machine the air gap is non-uniform?
I'm thinking just the silent pole non-uniform, non-silent pole uniform.
Okay, so you are thinking that non-silent pole having non-uniform or uniform air gap.
Non-silent pole uniform air gap.
Okay, so silent pole having non-uniform. Am I right?
Yes.
Yeah, great. That's the fourth difference. Non-uniform air gap. Now the thing is that why I'm asking this thing to all of you, because the basic fundamental of finding xd and xq or appearing xd and xq in silent pole machine is only this factor, non-uniform air gap. While in non-silent pole or cylindrical machine we are having uniform air gap. That's why the xd and xq, they are not presenting in any types of non-silent pole machine or cylindrical mode machines. While in xd and xq, xd and xq always appearing for the silent pole machine where I'm finding non-uniform air gap. That's the main concept to perform this test before. So just I want to know that all of you have got the idea why I have taken this topic, difference between silent pole machine and non-silent pole machine. Okay, so now one more thing. Now just I want one more thing be clear to all of you. So if I'm talking about the two pole, just wait. If I'm talking about two pole machine, two pole silent pole machine, so you can see structure looks like that. Structure looks like that. Clear? Here also I'm drawing something. Drawing is not so good, but just you can understand. I'm making a circle. It's not looking like circle, but just you can understand. Okay, and second circle I'm taking another color. This one. Clear? So here you can see this is stator. Sorry, this is stator. Okay, this is your rotor, this is your stator, and now you can see this is your length of air gap. So you can just erase, you can just clear this drawing. I can see this, you can see clear. This time I'm trying to erase this one. Okay. Just wait, just what I'm drawing again. Okay, just I'm taking this one. Now what's going on, you can see this is your field axis and there are two axes are there. So if you can see, this is your xd and this is your xq. Have you got the idea what I'm drawing here? Because this is already syllabus I've completed in your classes. xd and xq, are you getting my point? Okay, no problem. So actually just what I'm saying, so here some field is there. So this is the difference. Now you can see this is the length of air gap here. So when that is on in the, that you can say the field axis, according to the field axis, along the field axis, the 0 degree, you can say whatever. So here your length of air gap will be minimum. LG will be minimum when it is coming along field axis, clear, at 0 degree. And whenever it is perpendicular to the field axis, at that time LG will be maximum. Now, clear, at field axis, it LG is minimum and along 90 degree, it is maximum. So what's going on? If you have remembered the formula, Sg equal to L upon mu A. This is the formula for S, reactance, if you remember, where mu equal to mu 0 into mu r. Now can you tell me what is the mu r, value of mu r and mu 0? Leave that mu r. Anyone? What is mu r for air gap? What is mu r for air gap? What is the value of mu r? No answer. What is the value of mu r for air gap? Am I audible to everyone? Okay, the value for mu r for air gap is 1. So that we can say Sg equal to Lg upon mu 0 into A, where mu 0 is a constant. Okay, where mu 0 is a constant. If I'm keeping constant area, at that time your Sg is directly equal to Lg. Now, if you remember MMF, another formula, motive force, that is always equal to phi into S. Clear? So we can say phi equal to MMF divided by reactance, that is called S. Now, if I'm saying the production of MMF, or because the magnetomotive force is always constant due to some n into I number, that is number turns into current, because MF equal to n into I. If I'm keeping this constant at that time, if you are decreasing Sg reluctance, flux will be maximum, and if you are increasing Sg, flux will be minimum. Clear? So the thing is that something is going to happen here, and that's why some reactance will be changing and that effect will be changing. Okay, so this time setting the screen, just wait. So that I have already said, when crest of the rotating armature, what is the crest? That is called crest, means that circle. Just I'm saying this figure that you can understand. This one, suppose I'm saying this crest, I'm saying this is the MMF for this one. Clear? So when crest of the rotating armature MMF is in line with the field pole axis, minimum air gap offers, that already I've said, if you remember in that diagram. Clear? Means when crest of the rotating armature MMF is in line with the field pole axis, minimum air gap offers minimum reluctance. Clear? That is called XD. Thus the current required in the armature for the establishment of constant air gap flux must be minimum. Clear? So that is called XT. What I'm saying, ST, whenever your armature MMF is in line with the field pole axis. What is the field pole axis? That already I've said. If I'm doing this diagram again. Clear? So only for better understanding, suppose I'm saying this, I'm giving a roughly diagram. So suppose this is there two axis. Sorry, not this one. I'm just erasing this one. This is the field axis, this one, okay, and this one. So this is the field axis. So they are saying like that. Clear? So when crest of rotating armature MF is in line with the field pole axis, minimum air gap, you can see this air gap is minimum, this one. Clear? At the test point, air gap is always minimum. Clear? While when it is going for the perpendicular to the pole axis, at that time you can see this is maximum air gap. So when crest of the rotating armature MMF is in line with the field pole axis, minimum air gap offers minimum reluctance. Thus, the current required in the armature for the establishment of constant air gap flux must be minimum. Now, constant applied voltage minus the minimum impedance voltage drop in the armature terminal gives maximum armature terminal voltage. Again, I'm repeating, constant applied voltage minus the minimum impedance voltage drop in the armature terminal gives maximum armature terminal voltage. Thus, the D axis reactance, that is called XD, is given by maximum armature terminal voltage per phase divided by minimum armature current per phase. Clear? That is called determinants of XD. Next one, what is the procedure for slip test? First of all, what we have to do, check the phase sequence and voltage of the signal machine and the bus bar. Remove the field excitation and connect RYV terminals of the machine to RYV of bus bar through a three-phase barrier. Start DC motor and adjust its speed near to signal speed. Please keep in mind, start DC motor and adjust its speed near to signal speed, which on the AC supply. Clear? Switch on the AC supply and apply small voltage, very small voltage. The voltmeter connects across the field winding should fluctuate and remains within the rated value. If the slip is small and the direction rotation is correct, the armature current should also fluctuate. Increase the AC voltage applied to the armature very slowly from the barrier, such that maximum current is nearly equal to the rated full load current of the armature. Note down the maximum and minimum value of armature applied voltage and current. Calculate the applied voltage per phase, VP, that is called phase voltage, line voltage divided by √3. Record the readings for different applied voltage and we'll find the average minimum voltage, average maximum voltage, and average minimum current. Then we can find XT equal to average maximum voltage divided by average minimum current. This test already performed in the physical lab, don't worry. Clear? So this is the procedure for the slip test. In any question in your mind, you can ask here, first of all. What is the meaning of silent pole? What is the meaning of non-silent pole machine? What is the basic difference between silent pole and non-silent pole machine? And one more question, that what is the meaning of slip and why we are performing slip test? XT and XQ, why is it always present in silent pole type machine? It is not present in non-silent pole type machine. What is the basic concept behind that? What is the meaning of pole axis? What is the meaning of field axis? That you must know. Clear? So first of all, tell me how many are well familiar about the XT and XQ. I'm just sending the syllabus to all of you. Just wait for a subject also, so that you can idea that which topic I've covered already. I think so this topic I've covered, so you must know. If you don't know that, that is not good for all of you. So just I'm saying, because most of all your syllabus and GT syllabus mostly common. So I'm sending the screen to all of you in this terms of syllabus. We can discuss here. So all of you can see the PDF file for the syllabus also. All of you are listening me?
Yes, sir.
Yes, sir.
So all of you can see the PDF file also, am I right?
Yeah.
Okay, there is only 4 person now. It's Estelo and Joshua, Charles, Malayalam, and one more person have joined. What is the name of that guy? I've just forgot. 5 persons have joined basically. Malayalam, Charles, Joshua, Ismail. One person have joined. I'm not remembering the name. And where all the remember guys? Just I want to know where all the remaining guys? They're not joining any session. Why? Anyone? Can you tell me where all the guys? Other guys?
I don't have idea, sir. Maybe they will join next.
But that's not good actually. I just want to know because I think so everyone must join the session. Yeah, that's why, because it's the online session. It's supposed to be offline, so online everyone can join. If they are doing some work, they are from them side. So I think so they can join. Okay, no problem. So if they, where is the Veketu and Adisu? Where are the guys? Okay, no problem. So just tell me. I just want to discuss to all of you because already I want to meet to everyone, but that's not possible meeting because already when you are not attending the lecture, then how can you come to meet me? So just I want to know, first of all, you can see this topic, what I'm asking here. Tell me only one thing, that this topic have been covered. Just tell me. You can see the whole unit because already I've got only these two topics. These 3 topics I've covered. Whatever sir told me, he told me that this is topic is remaining only. So I have covered this topic only. Effect of harmonics, conjugate and crawling, effect of unbalanced voltage on performance of motor. These topics I have covered. But before these topics, like everything is done. Just tell me, have you seen your syllabus? Has it been complete? Because already I have started this unit. First I've completed, if you remember. First I have completed, okay. And second, I have already started, that is called single frame induction motor that I have started. The first I have already completed. Not only I completed, I have completed only 3 topics. Whatever Pavak sir told me that this is only remaining. But before these all topics have been covered, just I'm making confirmation from all of you. Is it or not? So no answer. Have you seen the syllabus? Okay. Yes, we have completed. Good. That's good. So Malayalam already have said EIE completed. Done. Okay, next second unit already we have started. If you remember this one, already I have taken the last lecture, constitutional features and double revolving field theory. This topic we have covered in the last lecture, if you remember. Clear? This topic we have covered in the last lecture. Already I'll provide all PPT to all of you. That what we have covered till now, we will provide PPT also. So constitutional features of single field induction motor we have covered. Double revolving field theory we have covered. Okay, so in next lecture I'll go for this one. So this topic I'll cover as soon as possible also. And furthermore, I just want to know that in this unit, in the third unit, all topics have been covered. This one, constitutional features, cylindrical rotor to machine, that is called non-cylinder pole, generated EMF, equivalent circuit and phasor diagram, armature reaction, synchronous impedance, voltage regulation, methods to find voltage regulation, synchronous impedance method, MMF method, ZPF method, operating characteristic of machines, cylinder pole machines, two reaction theory, power angle two reaction theory that is coming from XT and XQ, and power angle characteristic parallel operation of alternators, and this is already covered. This unit have been completed or remaining. Just take a look and reply. You can check your notes also. You can check whatever. You can check your notes. You can check your PDF or PPT, whatever you have. And if you have made the note, that's too good. If you didn't make any notes, so try to make a note first of all. Why I'm saying so? Because today I will decide the syllabus of mid-sem 2. Clear? So that's I'm asking to all of you. Give me a confirmation that if it is covered, then I will decide the syllabus. I will draw the paper to all of you. For that's I'm asking. I always make it confirmation from student side also. That give me confirmation. This topic have been covered, which didn't have covered. So Meherat, can you listen me? Meherat, can you listen me? Just you have joined now. Can you listen me? Okay, I think he can't listen. No problem. So the thing is that, so I will discuss to Nirtolias also, clear, and today I'll decide the syllabus that based what topic we have covered. Already in my topic, already I said I have covered these two topics. So please keep in mind the topic must be in mid-sem also. In mid-sem 2, I will discuss at least this topic, and I will also add at least this topic also. This unit I will try to add this unit. I will try to finish this unit in this week. So keep in mind, single phase induction motor I will apply in the mid-sem 2, and whatever the last topic that I have remaining from the power set that already have covered, that is the syllabus for the mid-sem 2 from my side also. And whatever the rest syllabus will be coming from synchronous machine and as well as synchronous motor also, that in number 4, this one. Clear? This fourth unit that will be also covered in your mid-sem 2. So first I will ask to the Niratolia sir and decide the syllabus also. And by tomorrow morning and maybe tomorrow evening, I'll provide the syllabus to all of you, that which one is coming mid-sem 2. Please keep in mind, all of you take care of the mid-sem results, because that will be assessed by the faculty member, and that will be added to in your internal marks also. So whatever you have the syllabus, please start reading now, because I just have decided on meeting to all of you. Clear? And in that meeting, I'll discuss all the things that what's going on now and what have done before, and what's the planning for future exams now. Clear? So it's a better thing to all of you that please start reading now, because already I have seen many times if I'm taking lecture or labs, only one or two participants there. Only 1-2% of joining the lectures also. Clear? So that's not good thing. Seriously, I'm saying that's not a good thing. So according to me, it must not be there. Clear? So start attending all the lectures within time. If there is any problem in your syllabus, if there is any problem in academic, what we have done before, because this is my first lab that I'm teaching to all of you, so that's why I'm saying. So already, if there's any problem in teaching or something, the problem is you're facing, so you can consult to me. You can say, you can give any suggestions to me if possible. Clear? So the thing is that first of all, we have discussed a lot about that one. So I'm just stop the sharing now. Clear? And I'm coming back to the point that already we have discussed about this test. So there is any question in your mind in this about this test? Already I've said. If you remember, any question about this test? There is any question?
Test about what? The next one? Next mix?
Sorry?
You are talking about the next midterm exam.
Yeah. I'm concerning. I'm discussing about the midsem 2 syllabus, because midsem 2 will be in that second midsem exam will be there. I think so. It will be it will be started from the 23rd. Am I right? It will be started from 23rd, 24th. Am I right? Have you got your midsem? Have you got your exam timetable that is called midsem 2?
Not yet, sir. Just no one posted that one.
Sorry?
We haven't get the timetable still now.
You didn't get the timetable, am I right?
Yeah, but I think there is a login.
Okay, no problem. I'll give the timetable to all of you. Don't worry. I'll give the timetable to all of you. So no problem. So actually, the midsem 2 will be working. Midsem 2 that already have done for all of you, or it is remaining? Tell me first of all. You have appeared only one midsem, am I right? Or 2 midsem till now?
One midsem.
One midsem. So midsem 2 will be there. That's I'm saying. So that's I'm saying midsem 2 will be there, and that's I'm saying first of all started now. So all of you have got pass in midsem 1 for this subject for EM2. Actually, can you give me your marks for the midsem 1? For this subject, what is the marks?
Actually, there is a problem, big problem, sir.
No, for this subject I'm asking. For this subject, for EM2, what are your marks? Actually, can you say?
For the electric machine.
Yeah, electrical machine.
24.
24, that's good. Out of 30, am I right? Joshua, your marks? Joshua, your marks? Charles? Joshua, can you listen me?
Yes, sir.
Joshua, Charles, can you give me your marks of EM machine 2 for midsem 1?
The results are already out. I have not checked.
You didn't check now? You must be checked.
Yes, I thought the results is not yet out.
You must check it. You must check it. Okay. Hagos, can you give me your marks for the EM2 for this subject? As I will take from net also, I will download the marks to all of you, but I just want to know from you. Okay. So no problem. So what I'm trying to speak here, first of all, please now start the preparations for the subject. Clear? Electrical machine is a good subject. So start the preparations and start reading now from the basic, first of all. Clear? And this test that already we've discussed today, what we discussed today, we've discussed what is the slip, first of all. What is the importance of low slip or high slip? the disadvantage, and what is the meaning of slip test? Why we are performing this test? First of all, that is called determination of xt and xq. What is the meaning of xd and xq? What is the meaning of direct axis and quadrature axis? That we have discussed. After that, what we have discussed, that effect of length of air gap in silent pole machine. Clear? What will happening if silent pole machine, if your length of air gap is very, very small at the crest value of armature mm, and at the 90 degrees very, very large, we can see. So what will the effect from the, what will be the effect of air gap length on reactance? What will be the effect of air gap length on mmf and flux, whatever? So that we have discussed today. And so that's why on the basis of these effects, what will be the effect on xt and x, that is called reactance of the xt and xq? How can you find this one? And also we have discussed that is called difference between silent pole and non-silent pole machine. So we have given the procedure to all of you. We have given the theoretical knowledge of this experiment. Clear? So now we will move to next experiment also, and we'll perform 2 experiments in next lab together. Clear? So today we have discussed, that is called number 6 we have discussed. I'm just going back. That is called list of experiment. You can see this one. So in next lab we'll perform this 6 experiment, as well as this is called 7 experiment. So now what is 7? 7 is called to perform synchronization of 2 3-phase alternator and observe the effect of change in excitation and speed on load sharing. Now first of all, tell me, to perform synchronization of 2 3-phase alternator, what will be the conditions? I think that this topic must be covered in the syllabus. What will be the conditions if you are putting, or if you are working on 2 parallel alternators? There is any condition? What I'm asking, give me the conditions to perform parallel operation of 2 alternator. I'm writing here. Give me the condition. It's a question number 7. Give me the conditions to perform parallel operation of 2 alternator. To perform parallel operation of 2 alternators. So there is any condition, or we can perform, or we can run any 2 alternator in parallel? Or we have to something we have to check, that is called pre-check we have to done. There is any condition to perform parallel operation of alternators? Tell me, I'm just giving you time. Okay, so give me the condition number 1, condition number 2, condition number 3, and if there is any furthermore. And my question is that what are the conditions to perform parallel operation of alternators? Any conditions there? No answer?
Yes, sir.
Please give me answer. Conditions to perform parallel operation of alternator. Is there any condition requirement, or any 2 alternators can be run in parallel at any time without taking anything?
I think there is necessary conditions are there in parallel operations of alternators. One is that the phase sequence of the bus voltage of the machine must be the same.
Okay. First of all, I'm telling to all of you though, what is the meaning of synchronizing? The meaning on the word that is called already you can see in that text number 7, synchronization. So first of all, you must know what is the meaning of synchronizing. The process of connecting 2 alternators, okay, the process of connecting two alternators or one alternator and infinite bus bar system in parallel is known as synchronizing. So whenever we are connecting two alternator, clear, that process is called synchronizing. Clear? That process is called synchronizing, means the process of connecting two alternators or an alternator and infinite bus bar is called in parallel, especially in parallel, keep in mind, it's called as synchronizing. Now, there are two types of machine. There are two types of alternator we can say. One is called running and second is called incoming machine. So what is the meaning running machine? Running machine is the machine which carries the load. Clear? Because what I'm doing here, one alternator is there. It's alternator 1. And this is alternator 2. Clear? So this is already running. This is already running. What I'm doing, I'm just trying to connect this alternator 2 in parallel operation of 1. So this is called running machine, which is already carrying the load, and this is called incoming machine. Are you getting my point? One is already running and second is called incoming. So running machine is the machine which carries the load, which already is carrying the load before. And second, what is the incoming machine? Incoming machine is the alternator or machine which has to be connected in parallel with the system. So this is your second will be connected. Second will be trying to connect with one in parallel. So for connecting, for this synchronizing between 1 and 2, some conditions are there. Number 1, the phase sequence of the alternator 2, clear? The phase sequence of alternator 2 voltage, that is, suppose I'm saying this is B1 and suppose this is called B2. B2 is called voltage of incoming machine, or we can say second alternator. And V1 is called voltage of first alternator, which is already carrying the load. So first of all, the phase sequence of B2, the phase sequence of B2 must be similar of phase sequence of V1. Are you getting my point? Are you getting my point? Must be equal or identical, we can say. Second, the RMS line voltage, clear, of the running machine and the incoming machine should be same. The RMS line voltage must be similar. The phase angle of both systems must be equal. Are you getting my point? These are some conditions. And the most important number 4 condition, the frequency of two terminal voltage, that is called alternator 1 and alternator 2, clear, should be nearly the same. The frequency that is, suppose this is working for the both alternator must be operate at 50 Hz frequency. So have you got the point? Phase frequency of voltage must be similar, clear. The phase angle of both system must be similar, and the frequency of the both system must be similar, as well as the RMS line voltage must be similar for the both system. So this is called conditions to perform parallel operation of alternator. Have you got the point? Now, suppose I am giving a picture to all of you. Suppose what I'm saying here. Suppose this is your generator 1. Suppose this is generator 1, G1. And suppose this is your G2. It's G2, it's G1. Now, this is your load. So how it works, first of all? How this happening, that is called parallel operation of system. So first of all, this is directly connected because already I said this is a running machine. Clear? Already I said this is running machine. So I'm just connecting this directly to the load. Clear? So generator 1 is directly carrying the load. Now what I'm doing here, I'm just trying to connect. So I can take another color so that better understanding. I'm just taking another color to connecting. And just I'm making this switch S1. Similar, I'm making switch S2. And this is your S3, we can say, whatever. So don't go for the exact diagram, but just I'm trying to speak. And just I'm connecting, this is your second. So when I'm performing this test, your diagram looks similar like that. Both alternators are getting the same load, clear. And what I'm just trying to connect the second alternator, clear, second generator to carry the load. So that is called parallel operation. Or we can, this is the condition of load sharing, we can say. Clear? So these are the terms are there to make the terminal voltage equal. This can be done by adjusting the terminal voltage of incoming machine by changing the field current and make it equal to the line voltage of the running system of using the voltmeter. So that we can do. Now, if you are saying that how can you change, how can you see the voltage true? So that's I'm saying for case number 1, to make the terminal voltage equal, what we can do, this can be done by adjusting the terminal voltage of incoming machine, means that is called incoming, means that is generator 1. So the terminal voltage of generator 1 by changing the field current, clear, and make it equal to the line voltage of the running machine, that is called generator 2. Clear? So there are two methods to check the phase sequence of any machine. They are like, first one is using, that is if you remember in the course also, it's called synchroscope. Synchroscope. If you have remembered this word, SYNCHRO. Have you heard the name of this word? Synchroscope, have you heard? To check the phase sequence of operating two parallel we can say to check the phase sequence of operating two parallel alternators. Or we can say second method is also you have heard, I think so you must heard about 3-lamp method. Have you heard about these methods? 3-lamp method to check synchronization of, or we can to check the phase sequence of any parallel operating two alternators. Are you getting my point? What I'm speaking, that topic you have already have you have read in the syllabus before. Parallel operation of two alternator have you done in your theoretical classes, or it's remaining? Okay, so I don't think so that you must you want to give answer here. Okay, so again I'm just I'm coming to back my screen on the presentation. So already I said in the next lab I will perform, that is already I performed 6 experiment that already I've done theoretical, and we have completed the theoretical portion of these 2 experiment 6 and 7. In next lab we perform physically that experiment number 6 and 7, because this weather condition only for maximum to 4 to 5 days. So whenever the next lab will be coming, okay, at that time all of you have to attend the lab in physical mode, and we'll perform experiment number 6 and 7 in physical mode. That will take most probably that will take only 30 to 35 minutes. Okay, and in next lab also I'll discuss the 8th experiment. So today what we have done, today we have discussed about a lot of discussion is going already have gone, and today discussion we have discussed about the experiment number 6, that is called to obtain d-axis and q-axis reactance, clear, of 7-pole machine sleep test. And also we have discussed about the parallel that we can say conditions of parallel operation of two alternators, and what is the meaning of synchroscope, what is the meaning of 3-lamp method, how can we check phase sequence of two operators, two alternators which is working in parallel, clear, and what is the meaning of load sharing that we have discussed a little bit. So in next lab, first we'll complete the basic theory of experiment number 7. If it is remaining, we'll discuss about the circuit diagram of experiment number 7, and then we'll perform and we'll take the observations or readings from that both experiment. And in next lab, you have to complete your both experiment number 6 and 7, clear, in file page. So kindly, whenever you come in the next week in the lab session physically, please carry the file pages, which is one side is the lining and second side will be blank, clear. So now you can write your roll number in the chat box, and we'll end the meeting. And it's very best request to everyone that please now start your reading, clear. If there is anything that if you are getting that we are not getting that thing, this is not completed, you can ask to me, you can come to me. But before coming, already that what I'm trying to speak, what's happening most of the time, what's happening, always you're coming at the last time you are coming, clear. So don't come at the last time. So please try to study now, clear. And whenever you are facing any difficulty in a study or whatever you're facing any difficulty in syllabus, you can come to me, we can discuss everything, clear. So please write your roll number in the chat box. Thanks to all who attended here, and please motivate your colleagues also to attend the lectures in physical mode. This is only for this week due to any weather conditions, so that's why I'm saying. So don't think like that now lectures will be online. No, lecture will be offline properly only after fulfilling these weather conditions. Clear? So please write your roll number in the chat box, and after writing your roll number in the chat box, you can leave, and we'll end the session now. Only we have got roll number 6, roll number 4, 3, 5. 3, 4, 5, 6. Charles, you can write your roll number in the chat box. Roll number 10. Okay. So roll number 3, 4, 5, 6, and 10. Any more person have remaining? What's the number of Marath? It's roll number 3. But there is 7 person have joined, but only have getting only roll number 3, 4, 5, 6, and 10. 3, 4, 5, 6, 7, 10. So I think so there one number is remaining. No problem, I'll check. So thanks to all of you. I'm just ending the session now. And if there is any question in your mind, you can ask me. Okay. So and those who are roll number 13. Okay, that you have to write in the chat box also. Yeah. So I think already I have got more numbers from all of you. Okay, so no question. I'm not seeing anywhere any question in chat box, and no one is speaking here. So I hopefully that whatever I've discussed today in lesson number 6 and 7, it is well understood to everyone. And whenever you're coming the next session, please come with 5 pages. We'll perform the practical. We'll take some readings, and we will make all calculations regarding that. Okay. So thanks to all of you. Thank you for joining here.